Okay, here are the solutions for the transformations in binomial expansion mock exam. The graph of a function f is shown in the diagram below. The point A, which is -1, is on the graph, and y equals -1 is the horizontal asymptote. y equals -1 is the horizontal asymptote. Okay. Let g of x is equal to f of x minus 1 plus 2. On the diagrams, sketch the graph of g. Now, if you have done enough problems, you know that f of x minus 1 indicates a translation to the right by 1. Okay? So f of x minus 1, although the minus might make you think that it's going to the left, in this case it's going to the right. For horizontal it goes to the right. Okay, so f of x minus 1 makes point A go to the right, and then plus 2 makes the y go up 2 units. Okay, so the new point is going to be right there. Okay, and it says to sketch the graph of g. So, for example, point A goes up there, and then it would look kind of like so this point would also go 1 to the right and 2 up. So we go through there, about. And then on this side, it would go about there. Okay. So that's basically what G would look like. And then write down the horizontal asymptote of G. Well, if you remember, this the G went up 2 units, so the horizontal asymptote would also go up 2 units. Now G went to the right 1 unit also, but the asymptote going to the right doesn't really change the asymptote. So the asymptote is now going to be here, which is at y equals 1, right? So the new equation for the horizontal asymptote is y equals 1. Let A prime be the point on the graph of G corresponding to the point A. Write down the coordinates of A prime. And we already marked it here. We just didn't say it was A prime. So this is A prime. A prime is, the coordinate of A prime is 0, 3. 0, 3. So in this case, remember, f of x minus 1 means 1 unit to the right, and plus 2 means 2 units up. Okay, so that is why the point -1, 1 has become 0, 3. Okay? Alright, next page. The sketch shows part of the graph of y equals f of x, which passes through the point -1, 3, and 0, 2, 1, 0, 2, 1, and 3, 5, and it marks all these here. A second function is defined by g of x equals 2 times f of x minus 1. Okay, so the function f is this purple one here, and it has these 4 defined points. And now we're going to look at this function, which has 2 transformations done to it. The first transformation is f of x miness 1. That should look familiar. It's the same transformation was done up here. f of x minus 1 is 1 unit to the right. Okay, so 1 unit to right. And then the 2 multiplied times f of x minus 1 is a expansion in the vertical direction. So it's a vertical expansion in by a factor of 2. Okay, so all the distances from the x-axis are doubled in this case. So, for example, first thing we're going to do is we're going to move it over 1. Okay, so point A moves over 1, point B moves over 1, point C moves over 1, point D moves over 1, point E moves over 1 in the right direction. So it kind of looks like this. Okay, so that's 1 unit to the right. And then the next transformation that's going to be done is this multiplication by 2 on the outside of the function. And when you do a multiplication on the outside of the function, that is a vertical expansion by a factor of 2. So what does that look like? Well, if we're going to vertically expand the red function by a factor of 2, what we're going to do is we're going to take each one of the points on the red function and we're going to move it away from the x-axis by a factor of 2. Well, these 2 points that are on the x-axis, even when you multiply them by 2, 0 times 2 is 0, so they don't move anywhere. Now, what about like this point here? It is 3 away from the x-axis. We multiply by 2. Now it's going to be 6 away from the x-axis. Okay, so it kind of looks like that. This point here, it's 2 away from the x-axis. Multiplied by 2, it's going to be 4 away from the x-axis. And then, let's see, this point here, it's 1 away from the x-axis. Move it away by a factor of 2. And it's going to be 2 away from the x-axis. Finally, here we're 5 away from the x-axis. Multiplied by 2, it'll be at 10. So the resulting transformation looks kind of like that. Then we're supposed to calculate the values for g of 0, g of 1, g of 2, and g of 3. So that would be the following points here. I'll mark them with this blue pen. So this point, g of 0, g of 0 is this one. G of, let me erase that one. G of 0 would be that one. G of 1 would be this one. G of 2 would be that one. G of 3 would be that one. And G of 4 would be, there is no G of 4. Okay. So basically we're going to have G of 0 is 6. G of 1 is 4. G of 2 is 0. And G of 3 is 2. So we could just put those values right here. Okay, G of 0 is 6, G of 1 is 4, G of 2 is 0, and G of 3 is 2. Okay, and this is on the same axis, draw the graph of the function g of x, and we've done that here. Just to figure out the answer for A, we've already done B. Okay, number 3. Okay, so on the test, you are going to be able to use your calculator. It helps you sometimes for the binomial expansion problems, especially if you have a high order binomial expansion. On the ones on this mock exam, they're pretty small, so you don't have to use the calculator, but I'm going to show you how to use the calculator so you'll be accustomed to using it in the future. Now remember, if you look at the formula sheet, it'll tell you how to expand your binomials. It gives it in this kind of notation. It gives it to you with n, r, and then a to the n minus r, and b to the r. And so each one of the terms looks like this, okay? And this formula here, the n over r, it's simply the formula which gives you the terms for Pascal's triangle. So each one of these terms can be figured out using um, this formula, which is a binomial coefficient. Okay? So let's see what this is going to look like if we expand this. Well, we could use Pascal's triangle and we could get the coefficients 1, 4, 6, 4, 1. Okay? Just from Pascal's triangle. We know it's this one because this is the giveaway, right? We're doing fourth order and this is the fourth row. Counting from this row, it's the fourth row. And then A is equal to 2, right? And B is equal to X. And so now we can write each one of these terms using this notation. Okay, so the first term is going to be 1 times A to the, in this case, we're at the r equals 0 term, so we're at A to the fourth, B to the 0, and then here we're at A to the third, B to the first, and here we're A squared, and B to the squared, and then here we're A to the first, and B to the third, and here we're B to the fourth. And we just multiply those with the coefficients, and then we'll get our expansion. And remember that A equals 2 and B equals X. So if we're going to write this out, we'll get 2 to the fourth X to the 0, which is just 1, plus 4 2 to the third X plus 6 2 squared X squared plus 4 times 2 times X cubed plus X to the fourth. Okay, and then we can simplify this. 2 to the fourth is 16. 4 times 2 cubed, 2 cubed is 8, so 4 times 8 is 32. 6 times 2 squared, 6 times 4 is 24. 4 times 2 is 8. And finally x to the fourth. Okay, so that is the expansion of 2 plus x quantity to the fourth. Then it asks us to find this multiplication, which is what we just got, and then we multiply it times this binomial, which is a different binomial. So the only way to do that is, this is the hard way, right? We're going to have to multiply the blue expression. First, we're going to multiply it times the 1, and then we're going to multiply, I'll use blue for that. We're going to multiply that expression times 1, and then we'll multiply the same expression times 1 over x squared. And we're going to get two different polynomials, and we're going to add those together. So first, we'll do the blue part, which is quite easy because we already did that. So the blue part times 1 is just the same thing. Okay? And then what if we do the red multiplication? Well, if we do the red multiplication, we're going to multiply each one of these blue terms times 1 over x squared. And that would be, let me just move this over a little bit, and you'll see why I'm doing this later. I'll move it a little bit over here. And then I'm going to take each one of these terms, like 16, and I'm going to multiply times 1 over x squared. And when I multiply 16 times 1 over x squared, I just get that. And when I do 32x over x squared, I get that. And then when I do 24 times x squared divided by x squared, I get that. And then when I do 8x cubed divided by x squared, I get that. And then when I get x to the fourth divided by x squared, I get that. And then I finished, right? And the reason why I put them staggered like this is because if I cancel out terms, like x squared cancels out with x squared, and x cubed cancels out with x squared, I end up with a remaining x to the first. And then if I cancel out x squared with x to the fourth, I get a remaining x squared. So you can see actually that, hey, look, these are x squared terms, and these are x terms, and these are constant terms. So we can add all these up and get a new polynomial. Like these don't add up with anything because there's nothing above there. But the 16 added to 24 gives us 40. And the 32x plus the 8x gives us a 40x. And the 24x squared over the 1x squared is going to give us 25x squared. And then the 8x cubed not added to anything is 8x cubed, and then x to the fourth is just x to the fourth. Okay, and what were they asking us for in the end? They were saying find the term in x squared. So that would be this term. That's the x squared term. So it would be 25x squared is the answer. They just wanted that one term. And you see how the 25x squared term is actually found from the 16 here. I'm sorry, it's found from the 24x squared here and this term here, x to the fourth divided by x squared. That's how you find that term. So you need like one term from the red equation and you need one term from the blue equation to find the total x squared term. Number 4, consider the expansion of 3x squared minus 1 over x to the 9th. How many terms are there in this expansion? Well, the number of terms in the expansions is always one more than the order. So like for example, when you have, and if you forget this, all you need to do is look at some simple examples. When you have an x squared function, it looks like this, right? So there's 3 terms in a squared function. So to the 9th, you would be doing 10 terms, okay? One more than the order. So you could just put here 10, okay? Find the, and if you don't remember, you could just like expand it out with Pascal's triangle. Find the constant term in this expansion. A constant term means the term that doesn't have any variable multiplied times it, okay? Normally, it's the last term, but look at this one. The a here is equal to 3x squared, and the b here is equal to negative 1x. With this very strange a and b, you're going to end up with a constant term in a different place, okay? And here, you're going to want to use probably the formula and the calculator. For example, remember this formula here? This is the formula for a term. And let's try to figure out which term we're looking for, because this is quite a big one. And if we don't know which term we're looking for, we're going to be writing a lot of math down. So basically, we're going to look for the term in which, let's see, 3x squared is going to be to the n minus r, and then b, which is negative 1 over x, and we could kind of write that like this, negative 1 over x, and that's to the r power, okay? And then we're going to have our coefficient, which is that, okay? So we know that n is the order of the polynomial, it's 9, so we can put 9 there, and we can put 9 there. We know that's 9. We don't know what r is yet. We can kind of figure out what r is because we know it's going to be the constant term. So basically, the x squared to the 9 minus r divided by negative x to the r is going to give us 1, because we know this is the constant term. The x's have to all cancel out. So if we know that x squared to the 9 minus r divided by negative x to the r is equal to 1, then we know that, and we could ignore the negative here, but we know that that's going to exactly cancel out. So which value of r is going to make this exactly cancel out? We could do this with algebra, but let's just guess a few numbers, and then I'll show you how to do it with algebra. So like, let's see, what if we had r equals 5? That's kind of right in the middle. So if we had 5 here, that would be 9 minus 5. That would be x squared to the 4th. That would be x to the 8th. And the bottom would be divided by x to the 5th. No, that's not it, right? Because x to the 8th divided by x to the 5th is not 1. Looks like we need to increase it a little bit. So what if we made r equals 6? If r equals 6, that would be x squared to the 9 minus 6th, which is 3rd, x squared to the 3rd, divided by x to the 6th. Hey, x squared 3rd is equal to 6. So that looks like it works out. So instead of r, we already know that r is 6. Okay. Now how would you have done that with algebra? Well, you know that 2 times 9 minus r is equal to r, because 2 to the 9 minus r was on top, r was on the bottom. We know that we're going to have the same power of x and they're going to cancel out. So that would be 18 minus 2r equals r. That would be 18 equals 3r, so r equals 6. Okay, that's how you would have done it with algebra. But you could just like guess a few numbers and you're going to get there. So let's cancel this, or like cross that out, and we'll just do the subtraction. It was 9 minus 6, so 3rd. Okay, so that worked out, right? So the term is going to be r equals 6, right? And so this is going to be a negative. That we'll bring back the negative here, and you can see that since it's the 6th, negative x to the 6th, this is just going to multiply itself out. It's going to be positive, and this is going to be 9, and r is, we just found it was 6. So now, what is this coefficient here? Well, as you did in the problem set, maybe you saw that you can find a, let's see, it's in the PRB menu. You're going to go down to NCR. Oops, and we need to put in the first value first. We need, so actually 9C6 here is equal to 9C6. So first we'll type in 9, and then we'll go to math, and then we'll go to PRB, and then we'll go to NCR, and then we'll put in 6. And that'll give us 84. So that'll be 84 x to the 6 divided by x to the 6. So the constant term is just going to be the coefficient, 84, right? Oh, I forgot one thing, 3x squared. So there was a 3 here. There was a 3, and it's also to the 9 minus r, so that would be 3 cubed. So in addition to the 84, you also have 3 cubed. 3 cubed happens to be 27, so actually you're going to have 84 times 27. Times 27, and that'll give us 2268. Okay, and you can also do this 9C6 or 9C6. You can do this using the formula, which is n factorial, r factorial, n minus r factorial, which means 9 factorial divided by 6 factorial and 9 minus 6 factorial, which is 3 factorial. Okay, and this is just equal to 2268 also. Okay, you can find that by going, hey, it's 9 times 8 times 7 times 6 times 5, blah, 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 to 1. 6 times 5 times 4 times blah, 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 to 1. And then times 3 times 2 times 1. And so like you can see that this part cancels out with this part. You're left with 9 times 8 times 7 on top, 3 times 2 on the bottom, and then you can multiply that out and you'll see that you will get, actually you're not going to get 2268, you're going to get 84, remember? Okay, so like the 3 cancels out with that, you get 3, the 2 cancels out with that, you get 4, so that'd be 12 times 7 gives you 84. Okay, and then when you multiply by the 27 here, then it gives you 2268. Okay? All right, so that is a pretty challenging problem. I gave you a challenging problem on purpose on the mock exam. This is harder than the problems I'm going to give you on the exam. But if you can do this, you're definitely set. And if you can't, try to do more problems to get ready for the exam.